Rise and shine, explorer. Day 8 has dawned upon us and has left us with no time to waste. Today, we're stepping up our game. We're going to add a dash of color to your monotonous existence by using a nifty piece of hardware called an RGB LED. Allow me to explain. RGB LED stands for red, green, blue, light-emitting diode. What this LED does is allow us to produce virtually any color on the spectrum by controlling the intensity of the 3 colored diodes. It's like your own personal rainbow producer. We're also going to cover a new function today, analog write. It allows us to send an analog output signal on a digital pin. Yes, I know what you're thinking. Didn't we just discuss how digital and analog are separate entities? We sure did. Let me, however, introduce you to the world of pulse width modulation, or PWM. This savvy little trick allows us to fake an analog output on a digital pin. Pretty neat, wouldn't you agree? Nonetheless, that's enough jabber for now. Rest assured, all this and more will be covered as the day progresses. Brace yourself in, explorer. We've got colors to mix and a spaceship to fix. An RGB LED is unlike your usual kind of LED, explorer. It's like a 3-in-1 special. Inside that tiny package, you'll find 3 separate LEDs, one red, one green, and one blue, as these are the primary colors of light. In a regular LED, you apply power and it emits a pre-programmed specific color. In an RGB LED, however, you have the ability to control each of the 3 colors individually. You can turn on the red LED, the green LED, the blue LED, or any combination of the 3. So, why is this exciting? Because by varying the intensity of each of these colors, you have the power to create virtually any color you want right at your fingertips. How deeply thrilling! Need a soothing aquamarine glow to relax? Easy. Want to flash a warning in bright alarming red? Ask and you shall receive. In essence, with an RGB LED, you're not just getting one color, you're getting the whole spectrum. Enjoy the possibilities, explorer. Okay, explorer, let's dig into 2 intertwined concepts, analog write and pulse width modulation, or PWM, which are critical for controlling our RGB LED. Analog write is a function in Arduino that helps us generate PWM signals. Despite its name, oddly enough, analog write doesn't really deal with analog signals. It's a bit of a misnomer, which could be a source of confusion. Have no fear, explorer. It'll all piece together soon enough. Moving on to PWM, pulse width modulation is a technique used to create a kind of fake analog effect using digital means. By rapidly switching a signal or power source on and off and changing the proportion of the time it is on versus the time it is off, we can vary the intensity of power that is received. This is important for our RGB LED because it allows us to control the intensity of each of the red, green, and blue LEDs, which in turn lets us mix our colors. Imagine PWM as a fast flickering light. If it flickers so fast that your eyes can't catch it turning on and off, the light will appear dimmer or brighter based on the ratio of on time versus off time. If it's on more than it's off, it appears brighter. If it's off more than it's on, it appears dimmer. In terms of our RGB LED, we'll use analog write to send PWM signals to each of the red, blue, and green LEDs. By changing the duty cycle of the PWM signal, that's the on time, we can control the brightness of each LED. By mixing different levels of brightness across the red, green, and blue LEDs, we'll create the color we want. You're in for quite a treat, explorer. The trajectory of your future will soon become a lot brighter, quite literally. It appears we've talked the talk. Now let's walk the walk, explorer. Our task today is to light up our RGB LED and give it a whirl. Remember, with pulse width modulation, we can tinker with the intensity of each color, from a meager 0 to a dazzling 255. Talk about a spectrum. Now, one way to control our RGB LED would be to separately define the red, green, and blue values every single time we want to change a color. But frankly, that's like choosing to walk across the galaxy when you have a perfectly good spaceship. It's slow, and it'll leave your code looking like a debris field of supernova. Let's be smarter, shall we? What do you say we build a function to streamline the process? Something catchy and memorable like set RGB red level, green level, blue level. You'll see those 3 byte variables nestled inside the parentheses, separated by commas. These are parameters, and we'll be handing them over to our function like instructions to a well-trained robot butler. We don't have a lot of memory, so since max value doesn't need to be anything higher than 255 anyway, remember, pulse width modulation, a byte is perfect since its max value just so happens to be 255. Using something like an integer for an unsigned number less than or equal to 255 is just a waste of memory. Once we're inside the function, it's time to put those parameters to work. We'll use analog write to set the value for each of our 3 color pins. Efficient and tidy, just the way I like it. In our main loop, it's testing time. We'll call our snazzy new function in a variety of ways to make sure our RGB LED isn't just sitting there like a lump of plastic. Once we're confident everything's shipshape, we'll beam it up to our board and enjoy the show. Let's get to it, Explorer. Lights, camera, code. Now, for what you've been waiting oh so patiently for, let's turn to some instructional material that I was able to gather cached on the computer. I've also added this to your mission resources for future reference. See you soon.
Well, what do we have here? It's a clean slate. That's what we like to start with. So if we go over here and we're in all basic components, we found our RGB LED over here. And I'm going to slap it right over here. So again, this is really awesome because now we don't need all these pesky LEDs all over our breadboard. And we can just kind of have one that we can alternate between the colors. We can find this very useful in sending notifications or just alerts going forward. So it's a little, let me have it separated over here. Red, cathode, blue, and green. So it's labeled very well for us, which is super helpful. But the one that stands out is obviously the cathode. So that's going to go right into ground. So let me put this back on the breadboard. It's easier to see this way. We're going to take that. And I'm going to do this extra little thing because I think it looks way nicer if you do it like this. And it future-proofs the circuit for us. Next, we're going to grab our resistors again. Okay. And I'm just going to set these 220. We're going to copy, paste. Okay. And now we need to match up the colors with what ones we want to use. So in this case, we're going to use 9, 10, and 11. So I kind of, let me see, I'm trying to figure out the right way to go here. We'll go down here, 11, and let's figure out, this one is red. So traditionally I'd be against using red for this, but we'll just simplify it. And we'll go blue here. To 10. We'll set this to blue. And the last one, green. We're going to set that to 9. There is a reason we did the ones with the tilde, little squiggly line right there. And as Astrid explained earlier, we're going to be using that to send a, lower amount of voltage or a high amount of voltage, depending on how intense we want that color. It's going to allow us to use a wide variety of colors here. So that's what the basic circuit looks like. We have everything, boom, connected to ground here. Again, it's labeled cathode. On an actual RGB LED, it'd be a long one. And then these ones are just separated. So super nice, easy labeled. And now we go into the coding. This is where it's going to get fun. We don't want blocks. We want the text. Yes, I am sure. All right, so there's a few different things we're going to need for this. We're going to define red. And we're going to set that to, it is 11. Let me make this a little bit more proper. Actually, our green pin's 9. I messed that up, so I'm gonna go over here. Find blue pin. Alright. All right, so now we have defined the pins so we can use it in our code. Now we're going to go into the void setup. We're going to take this. I'm actually going to quickly swap this out because we need to make them all outputs. Look how efficient this copy paste is. We like that. All right, so that's the setup done for us. All we really needed to do was just define that there were 3 outputs here. It's really all we're managing is the 3 different outputs. We don't got anything else going on. So now we can get straight into the loop. And to do this, we're going to actually write another function down here. I'm just going to delete all this so I don't need to see it. But really what I want to do at first is I'm going to write some pseudocode here. So this is code that won't actually work, obviously. I'm just going to leave it in comments. So we're going to have everything display 0 off. So everything's going to be turned off when we start. We're going to wait 1 second. And then we're going to set it red, set LED red. And then wait 1 second, set LED to blue. And then we're going to go green. So I'm just kind of planning out the code that I'm going to write here. It's a little different way of doing it. This is how I do like to write code sometimes. And then after that, we're going to turn it back off. And now we're going to get to the interesting colors. So we're going to wait 1 second, which actually should be here as well, before we turn it off. And then we're going to set LED. I'm going to call on my friend here. Alex, what color should we set it to?
Purple.
He's saying purple. All right. And then wait 1 second. I also realized that set LED purple. Let's do yellow. And then let's try an interesting color that we might not be able to get. We'll set it to white, which is all of them on, as Alex suggested. So this is what we're going to try to accomplish, and this is going to kind of give us a good grasp of all the different colors that we can do. So now we have our pseudocode written. Something that's really going to help us is creating another function down here that we're going to be able to call on to kind of run some code for us. So what we're going to do is void display color is what we're going to call it. And then now we need to set some parameters. Right, red intensity. It would be very helpful if I spelled this correctly. And then we're going to do green and then blue. So essentially what that's going to allow us to do is be able to set the intensity of red, green, and blue. And then we can essentially just follow one of the color wheels to decide on which ones we're doing and what amounts. So to do this, we need to do an analog write. And we're going to take our red pin. We're going to start with red. And we're going to set that to red intensity. Again, lazy wait is always the way for me. Semicolon to end this. And I'm noticing, before I forget, up here we do need commas between these because really it should look like this, but for readability, we have it. This is technically what it's saying, but for readability, yeah, we're just going to put that back. All right, and then we're just going to copy these over, and then we're just going to change it from red to green to blue. I honestly believe everyone should be coding by copy and pasting a lot of the times. It just makes things so much easier. That's how I learned, and it saved me a lot of debugging on the spelling errors because sometimes it can be rough. So to start, I'm going to kind of explain how to use what we just wrote, which is display color. So we take display color and we're going to put it on our code right here. And we have to feed it because we said it needs 3 essentially statements. So we're going to 0, 0, 0. And what this is going to do is it's going to set everything 0, which is off. This first one being down here, the red intensity, this one right here being green intensity, and this last one being blue intensity. And these values are from 0 all the way to 255. So if we wanted half red and nothing else, we're going to set this to like 120 something. And if we wanted it just to be green, we would set this, and we want to be really bright green, this would be 255. So we're going to follow that rule, and we're going to go ahead and build all these out. So I will put a delay statement in here, just so we can see things as we've shown before. All right, and then we're going to wait 1 second, display off, wait 1 second. So we've finished these 2, and now we're going to set it to red. So to set it to red, we're going to reference down here. All right, so it's the first one. We're going to set that to 255, which is full intensity red. And I'm going to edit this a little bit. We're going to, we'll come back. We'll do it down here. I'll show you like half intensity and whatnot. Maybe this first one. This will just be 120. So we'll set it to half brightness. Again, delay. And then we're going to go grab this one. We can actually type in here half power. Set. And then this one, we're going to go blue, full power. So that's going to be set in this. Blue is the last one. So we almost tricked ourselves there. We're going to go there. All right, now that blue is done, we're going to add the delay in. Wait 1 second. And now which one do we need? All right, let's set green. This is super low. Let's just do like a, 40 or whatever. So it's like a really dim green, just so you guys can see intensity, just again. All right, and it looks like we have completed our first round of pseudocode. All right, and then we're going to turn everything off as it states there. Delete that. Wait 1 second. Oh. All right, so before we get to this next one, I'm going to go ahead and test it, and then we're going to figure out how to display purple. So I'm going to go up here and start simulation. So it's following. It's probably hard to see intensity here. I'm not sure how much you'll be able to tell. So see how, just look at the green here, and let's go ahead and stop simulation. And let's go ahead and bump this up to 255 and see if we can actually tell a difference in the simulator here. Oh yeah, that's a lot more clear. And the green, yeah, it's a lot brighter. So you can tell a difference between the brightness. So I'm going to go ahead and stop now. All right, to get purple, Alex, what colors do we have to mix?
That's a good question. I don't know. I think it's blue and red.
He says red and blue. So let's take these and let's just see what color we get. You know what? We can delete these. We don't need to go through this again. And now what we do is we take this and we're just going to add this to here. And get rid of this and set purple.
Question mark?
Question mark? Because we don't know. We'll find out if it's purple or not. Let's see. That looks pretty purple.
Pretty good.
Let's see what happens if we set this down to 50. So it's a very strong, what color? Red. Would that be a pink? Oh, look at that. So you can play around with the values here. There's kind of no point for me to finish this. What I challenge you guys to do is try to come up with yellow and teal and see how you can come up with those colors. If you want a little hint, you can actually just Google it and look up the RGB values of any color that you want and have fun with it. Go explore, set up some cool lights, maybe revamp a little studio light, display. Just have fun with it. It's a very depressing scenario. We're all stuck in this spaceship, so you got to have some fun with it. All right, I'll see you guys in the next episode where we do things a little bit better than the way we did before. We're going to combine the light sensor, the photoresistor, with this RGB LED to charge the battery and kind of help display the percentage. And we'll put use to both of them. See you in the next one.